Step 1 is to find the roots. So set this equal to 0. So in order for this to be 0, either this is 0, or this is 0. So when this is 0, what does x have to be? X would have to be 0. How about for this one? In order for this to be 0, x would have to be equal to how much? 1. And for this one, x would have to be 2. Now we're going to plot all these roots. So x is 0, we're going to go here. X is 1, we're going to go here. And x is 2 is going to go here. Our next step would be to find the degree of the polynomial. So you can see here, x minus 1 has a multiplicity of 2. How about x? Wherever there's no exponent, I'm just going to put a 1. So x has a multiplicity of 1, x minus 2 has a multiplicity of 1. And what we're going to do is we're going to add these exponents. So 1 plus 2 plus 1 is how much? It's going to be 4. So I'm just going to write n is equal to 4, and that's the degree. Our third step would be to find a. So the number in front of all of these factors, which is how much? It's 3. So I'm going to write a is equal to 3. Step 4 is to graph the end behavior. So when n is even, it's either going to open up or open down. And when a is greater than 0, it's going to open up. When a is less than 0, it's going to open down. So for this graph here, which one would it be? Open up or open down? It's going to open up. So if it opens up, we'd have to start from the leftmost root and just go up like this. And also you can see here, we have to start from the rightmost root and go up like this. Let's go ahead and write out the end behavior. So as x approaches negative infinity, so that means as we go this way on x, what happens to y? So f of x, is y going up infinitely or is y going down infinitely? F of x is going up infinitely. So f of x approaches positive infinity. Okay, and how about if we go infinitely right? So as x approaches positive infinity, what happens to f of x? Are we going up or are we going down? We're going up, so we're also approaching positive infinity. Our last step is to graph the behavior between the roots. So we'll start here at x equals 0, and x equals 0 has an odd multiplicity because this 1 here is an odd number. And when we have an odd multiplicity, we're just going to pass through the root like this. And then if we have an even multiplicity, we have to bounce off the root, so it's going to look like this. And then we have another odd multiplicity, so are we going to bounce off or are we going to pass through the root? We're going to pass through the root. So let's go ahead and find and plot the roots. So set this equal to 0. So this gives x is equal to 0. This gives x has to be 1. Let's plot these. X equals 0, x equals 1. Okay, and then the degree. So I'm going to put 1 here. So the degree is 1 plus 2. So I'm going to put n is equal to 3. 1 plus 2 is 3. Now we need to find a, the number in front of the factors, but there is no number. So this is the same thing as 1 times x minus 1 squared. So yeah, I'll just put the 1 here, and a is going to be 1. And when n is odd, it'll go uphill if a is greater than 0, and it'll go downhill if a is less than 0. So for this graph, which one would it be? Uphill or downhill? So a is greater than 0, so it would go uphill. Let's go ahead and graph the end behavior. So we start at the leftmost root and would be going down, and then rightmost root would be going up. And let's just write out the end behavior too. So as x approaches negative infinity, so as we go this way, what's happening to y? Are we going up or are we going down? We're going down. So f of x approaches negative infinity. And as x approaches positive infinity, so as we go this way, are we going up or are we going down? We're going up, so f of x approaches positive infinity. Our last step is to graph the behavior between the roots. So for this root, x equals 0, do we have an odd multiplicity or even multiplicity? We have an odd multiplicity. So does that mean we have to bounce off, or are we going to pass through this root? We're going to pass through this root. How about for x equals 1? We have an even multiplicity, so that means we have to bounce off of it. So this is your graph. Okay, so the roots are here and here, which are how much? So we have -1 and +1 here. So that's going to give us x plus 1 and x minus 1. What did we do for our second step? We found the degree. So the degree of this one, well, what does the word quartic mean? The word quartic means that the degree is going to be 4. Our third step was to do what? Is to find a, but we already know that it's either 1 or -1. So which one is it? Since this one opens down, a is going to have to be negative, and our only negative option here is -1. So we're just going to put the negative over here. We don't need to put the 1 here. In our previous example, the last two steps involved graphing. So let's see if we can use this graph to figure out the multiplicity of these two roots. So for -1, so over here, are we passing through this point or bouncing? We're bouncing, so that means the multiplicity has to be odd or even. It has to be even. So I'll just write even here. And same thing here, this one would also have to be even. So we're looking for two even numbers that add to 4. So what's our only possibility here? It's going to be 2 and 2. So this is your answer. F of x is equal to -x plus 1 squared, x minus 1 squared. All right, so first step, find the roots. So what are they? -2 and 1. So f of x, so -2. So x plus 2 is here, and then x minus 1 is here. Okay, and then next step is find the degree. So cubic means degrees how much? It's 3. And then we need to find a. So for uphill, it's going to be, a has to be what? A has to be greater than 0. And then for downhill, a has to be less than 0. So which one of these is it? A is greater than 0. So our only option here where a is greater than 0 is 1. So if it's 1, we just don't write the 1 here. We just leave it alone. Okay. And then now what do? We need to observe the behavior at these roots. So for the -2, we're bouncing. So this has an even multiplicity, and then we're passing through this one. So this one has an odd multiplicity. So I write even and odd here. Okay, and so we need an even number and an odd number to add to 3. So the only possibility is going to be 2 and 1. So your final answer is f of x is equal to x plus 2 squared times x minus 1. I'll give you a second to read the problem. Got it? Good. Let's go ahead and draw our squares. All right, let's cut them out. Let's fold them in. Okay, and this is what the final box is going to look like. And we want to figure out how big we should make our squares in order to maximize the volume of this. Okay, so this is our original sheet of paper, 18 by 24. And we're cutting out squares from the corners like this. And the side length of the square is how much? It's x. So this length is x, this length is x, x, x. So this is going to be the base of our box. So initially, this is 24 inches long, right? And we're taking away x inches here and another x inches here. So how many inches are we left with for over here, which is the same length as this? 24 minus 2x, because we're taking away 2x in total. And for this one, what would it be? It would be 18 minus 2x. So the length of the box is 24 minus 2x. The width is 18 minus 2x. And the height is going to be this. So it's going to be x. So how are we going to find the volume of the box? Well, we need to multiply length, width, and height. So the formula for volume of rectangular prism is length times width times height. So length times width times height. So we want to find the value of x that maximizes this expression. We also have some restrictions. So we can't have negative length, negative width, or negative height. And they can't be 0 either. So this has to be greater than 0. Length has to be more than 0, width has to be more than 0, height has to be more than 0. And to solve this inequality, what do I need to do? I need to get x by itself. So I need to get this by itself. So let's add 2x to both sides. So 24 is greater than 2x. Divide both sides by 2, you get 12 is greater than x. For this one, you're going to get, okay, so 18 is greater than 2x, so 9 is greater than x. And then x has to be greater than 0. So we're going to just say 0 has to be less than x, which has to be less than 9. Because if you're less than 9, you're always going to be less than 12. Okay, so I put it into Desmo. So this is an online graphing calculator. And I also included x equals 0, x equals 9. That way we know to look in between those values. So I'm going to have to zoom in a little bit here. So we want to be in between the black line and the red line. So yeah, you see this point here? This is what we call a local maximum. It's the highest point in this area, this neighborhood. The x-coordinate is what we're interested in, so that's going to be 3.39 approximately. So that's your answer, and then the maximum volume is approximately 654.98. There's also a calculus solution to this. I'll make another video that goes a little bit more in depth into these kinds of problems, but I'll just include the solution here for the sake of it. It involves taking the derivative of 24 minus 2x times 18 minus 2x times x. And this is going to give you 12x squared minus 168x plus 432. And then we want to find the critical point. So we're going to set this equal to 0, solve the quadratic. You're going to get x is equal to 7 plus or minus root 13. And then we're going to do the second derivative test. So f double prime of, so we'll do f double prime of the critical point. So this will be 7 minus root 13, and then f double prime of 7 plus root 13. When this is less than 0, then this is going to give you a local maximum, local max. And when this is greater than 0, this is going to give you a local minimum. But yeah, f double prime of 7 minus root 13 is less than 0 here. And f double prime of 7 plus root 13 is greater than 0. So our local max is going to occur at x is equal to 7 minus root 13. This is your answer. I'll give you a second to read the problem. Got it? Good. So I'm taking a sheet of paper and I'm rolling it into a cylinder. And you can see that I'm also leaving an inch here. Yeah, an inch here for riveting. So I'm going to draw the sheet of paper here. I'm going to say this length is x. And the parameter is 24. So how long would this plus this be? Well, I'd have to divide 24 by 2 to get 12. So this plus this is 12. How long does this side need to be? It has to be 12 minus x, so this plus this is 12. And if we're going to roll along this side, then this side's going to turn into a circle. So like this. What would the circumference of the circle be? Well, the side remains unchanged, but we need to leave 1 inch for riveting. So we actually just have to subtract 1 from this to get a circumference of 11 minus x. We're looking to maximize the volume. So how do we find the volume of the cylinder? Well, we need to find the area of the base. So find the area and then multiply that by the height, which is how much? X. Okay, so to find the area, we need to find the radius. So I'm just going to use the formula circumference is equal to 2 pi times radius. Okay, so I'm going to set 2 pi r equal to this. 2 pi r equal to 11 minus x. How do I get r by itself? Divide both sides by 2 pi. Now we need to find the area, which is equal to pi r squared. So pi, r was how much again? R was this, so we're going to have to square this over 2 pi squared. Okay, and let's just simplify this. So pi times 11 minus x squared over 2 pi squared. So 2 squared is how much? 4. Pi squared is how much? Just put pi squared here. Cancel out a pi here. So this becomes 11 minus x over 4 pi. Okay, and then the volume is the area of the base times the height, which was how much again? It was x. Okay, so it's 11 minus x squared over 4 pi times the height, which is x. And I'm just going to rewrite this in this format, 1 over 4 pi x times 11 minus x squared. We also need for the height needs to be more than 0, and so does the circumference. So 11 minus x has to be greater than 0 as well. So if I add x to both sides, what do I get? 11 is greater than x. So combining this and this, I'm going to get 0 is less than x, less than 11. Okay, so I'm just going to put this into an online graphing calculator. And I graphed two lines, x is equal to 0 and x is equal to 11. So we know to look in between these two lines. And so this point here, that's going to be our local maximum. The volume, what's the volume going to be when it's maximized? It's going to be 15.69 approximately. And the value of x is approximately 3.67. The problem is asking for the dimensions of the sheet to maximize the volume. So this is our sheet. This is going to be x. This is going to be 12 minus x. So we said x is approximately 3.67, which means this would be approximately, well, 12 minus 3.67, so about 8.33. So 3.67 and 8.33. This is your answer. There's also a calculus solution. So 1 over 4 pi times x times 11 minus x squared. And we want to find the value of x that maximizes this. So we're just going to take the derivative. That's going to give us negative 11 minus x times 3x minus 11 over 4 pi. And we want to set this equal to 0. And if we set this equal to 0, we're going to get the roots are x is 11 and 11 over 3. So these are your critical points. Let's do the second derivative test. So this is going to be less than 0. And this is going to be greater than 0. So when the second derivative is less than 0, that's going to be where your local max is at. And this is where you go for local mins when it's greater than 0. So x is 11 over 3. The other dimension is going to be 12 minus 11 over 3, which is, so 36 minus 11, so 25 over 3. So these are your dimensions. This is your answer.